Hello again. Today we're going to talk about chapter 4, physical development. There's some interesting things. Quick reminder, I know I've said it before, but it's worth repeating. Um, we talk about physical development here in chapter 4, and in some ways it is, it's not a separate item. You can't separate physical development from cognitive development and social development. Later on, we're going to find out that, say, for example, boys that physically mature faster are more popular at school, and therefore, their social development is modified because of it. And girls that mature faster are seen, well, whatever. And when children develop physically faster, they're treated older by both parents and friends and teachers, and sometimes they're cognitively not advanced or cognitively at their age. They're socially at their age, but they're physically older. They look physically older rather, and so they're treated differently. So I mean, we're going to talk about physical development in some isolated, separated way. But remember, you can never really truly understand physical development without also doing cognitive development and social development. And we'll get to that, and moral development and stuff. And we'll get to that stuff. But we're going to start with physical separately. The average baby is born 7.5 pounds. We've seen this before. That's just a pretty good number. They lose weight in the first few days. That's a very scary thing as a parent because you're being told. I can't even remember what the rule was, but your baby should double in birth weight by such and such a time, and then at first your kid drops off, and it's kind of freaky. When babies are born, they don't eat that much, and it's kind of a weird thing, but mother's breast milk at the very beginning is different than mother's breast milk later on. And at first, it's just a different consistency, a different texture, a different everything. And the babies don't know what they're doing. They don't know how to breastfeed, especially if a mother's never done it before. She doesn't know what she's doing or how to get it done. And it's very frustrating as these mothers are trying to get this whole thing started and figure out what to do, and the baby starts losing weight. And it's very, very difficult, especially for women that they think, especially what we had maybe mentioned at one other point, women are told that breastfeeding is so important. Yeah, we did that in chapter 1, didn't we? Breastfeeding is so important, and if you don't breastfeed, then you suck as a mother and you fail, and the baby's starting to lose weight, and it's like, oh my God, just give the baby a bottle, and then the mother's like, oh my God, I failed, and it's a very stressful time. It seems pretty trivial, but it's very, very big. By 5 months, the weight is just about double. By age 2, the weight is times 4. They grow even faster this way. Newborns are typically about 20 inches long at birth, and they gain 50% of that in the first year. What am I? By age 2, they're already half their height, so that's kind of crazy. Then there are also times during development that growth is faster than others. Okay? Now we know about these things. Here is a girl's average weight and a boy's average weight. On average, girls have reached half of their adult body weight by 9 years old, whereas boys don't reach half of their adult body weight until age 11. Okay? And that's interesting. Girls mature earlier than boys. Growth is stimulated by hormones that are stimulated by sleep. Kids need sleep. That's not just a statement, that's a truth. The adolescent growth spurt is an increase that begins with the onset of puberty. It'll freak you out, but yeah, lo and behold, this, by the way, on this graph, this is the average gain in inches per year, and in the first year, the kid gains, 10 inches. In the second year, 5 inches. In the third year, this much. In the fourth year, the kid's gaining 2.5 inches a year, something like that, which is still quite a bit. But by the time they reach this adolescent growth spurt, girls have this growth spurt earlier than boys do. And here's a growth spurt in boys, and eventually that stops. I'm doing the math on this, and I'm in trouble because my son is already, he's 13, and he's just 1 inch shorter than I am. and I'm looking at the math here, and if this is true, then I'm 1.5 inches, 3. Holy crap! According to this, my kid's going to be 9 feet tall. I don't know. Hopefully, it doesn't work out. Okay, but this growth spurt is real, and for some kids, it just is a little bit earlier, and some it's a little bit later. When infants are born, what kind of physical control do they have? They have reflexes. Reflexes, which, if you will believe evolution at all, reflexes are behaviors which allowed babies to survive in the past. Involuntary muscle movements that are elicited by environmental stimuli such as sound, light, touch, and body position. The rooting reflex, where you touch a baby's cheek and hold. Okay, and they go like this. Not only do they turn, but then they and so, which is related to the sucking reflex. These are both. These together are the ones that that are for breastfeeding. The Moro reflex is basically a jump at a loud noise. The grasping reflex is anything that you put in the baby's hand, they just grab onto. We have some other things too. Certain reflexes go away after infancy. The grasping reflex. Yeah. All right. But other reflexes are like, I forgot the one, but they have this similar grasping reflex with the feet that does also modify as a kid gets older. We could refer to development in the gross sense and the fine sense. Gross motor development refers to coordination of the large muscles, which allows for things such as walking, and fine motor movement, which refers to the muscular control in the fingers and bones. Gross motor development, we already talked about the cephalocaudal pattern, head to toe. At 1 month old, the babies hold their head up. By 3 months, they roll over. At 6 months, they sit up, and about a year, they take their first step. Cephalocaudal, it starts at the top and moves its way down to the feet. Okay. Based on them, the proximal distal pattern is for the fine motor control. Here's a neat image. Examples of fine motor control. I like this. Around 4 to 5 months, they start to use a palmar grasp, like this. Right, we know that one. By 10 months old, they use a more pincer grasp. Oh, where's my camera? There's my camera. Pincer grasp, palmar grasp. By 15 months old, they can use a riding implement. Here we have an image. It's kind of dark here. Hold on a minute. You just be patient there, kids. That's still kind of dark, but you can see it on your copy of PowerPoint, right? And here's my 2 kids. My daughter was 15 months old, and my son was 6.5 years old. And as you can see here, he has very good control of the pencil. The thumb and the fingers are properly placed. He's got it all worked out. She, on the other hand, is just grabbing that pencil just as tight as she can. She's got it, and she's just scribbling away on that paper. Okay? I like that picture. That's a good picture. Here's an image that my son drew. Here it says, precise control over fine motor movements of the fingers comes much later than control over the gross motor movements. Here by age 4, they can write recognizable letters. Here's my son at 3.5, and here's his name. Adle. Yeah. And here's a picture of his family. Here's mom, here's dad. You see dad's even got a beard on there. That's a pretty good image. And there's my son. My daughter at 3.5. Amazing, I got both of these images. And here's dad, and here's mom, and here's her older brother, and here's herself. Okay? What an image that is. Very interesting. And nice colors too, I must add. Okay? That's not the light I wanted to use, is it? All right. Whoops, I'm trying to advance PowerPoint in there. So, dynamic system theory, if you recall, was the idea that all of these things interact with each other. So we find that neurological development provides opportunity for voluntary control. parental encouragement and interesting objects in the environment motivate the infant to exercise the control that their neurological development gives them. Opportunities to exercise give the babies, as cognitive systems mature, babies are able to remember where things are and are motivated by more curiosity. There's a lot of factors that influence motor development, including culture. Some cultures, babies receive more vigorous stimulation. In some African cultures, physical stimulation is emphasized. The interaction between infants and mothers in some African cultures is really kind of, it looks kind of weird to me, but they're holding them up by their arms and they're flopping them around and stuff, and these kids really, they're advanced in that way. Some South American cultures are more swaddling. They strap the baby on, and the baby can't move, and the baby just goes wherever mom goes. They fall behind on the major motor milestones, but later on, I mean, they all even out. They all even out in the end, but they're more advanced early, and they're behind early. Eating, all right, I don't know, I'm not your nutritionist, I guess, but we need food. We need food for a lot of reasons. Of course, we need food just for energy. Y'all know that one, right? Calories. But we also need food because they become the building blocks. That is to say, later on, we could talk about things such as neurotransmitters. And neurotransmitters, which we'll talk about a little later, require raw materials in order to create them. And those raw materials come, of course, from the foods that we eat. Carbohydrates are fuel, fats provide a source of energy, vitamins and minerals and calcium, blah, blah, blah. I think if you don't know this stuff, I don't know what class you should. Malnutrition happens when children don't get enough, either calories as a whole or vitamins and minerals. Here in the United States, starvation is pretty rare. In fact, we have the opposite problem, obviously. There is some cases where it happens and growth is stunted. You know, we talked about the idea of nature and nurture, that nature provides a leash and puts a maximum and a potential and stuff. Without the environmental stimulation, or in this case food, it won't work. Malnourished children perform less well in school. They continue to suffer intellectual deficits even as adults. And obviously here in America, less than 3%, and I think that I haven't seen those kids. I don't know where they live, but less than 3% of kids would be considered malnourished in America. But in some countries such as Bangladesh, India, or Pakistan, as much as 60% are malnourished. These are some crazy numbers, okay? In Southwest Asia, 38%. Here in America, however, we've got the opposite problem. We've got overweight. The most frequent nutritional problem in the U.S. is being overweight. Yeah, you know, we invented this thing, we mastered this thing called processed corn syrup, okay? It's a beautiful idea, but it's tricky because we as humans were naturally drawn to sweet stuff. You know, in our ancestral past, if something was sweet, you should eat it because that means it's got lots of calories in it, stuff that you need. That was when calories were scarce and calories were hard to come by. Nowadays, with the mastery of processed corn syrup, I drive past, in fact, you go to the gas station there, and you can fill up to 100 ounces of fountain soda for 99 cents. Do you know how many calories are in 100 ounces of a fountain drink? 99 cents? My God, I could find that stuck into the seat of my car. You know, that's not even money. 99 cents, 100 calories, there are 100 ounces. There's enough calories in that one bucket to last 5 days for an entire family in some countries. It's just, oh my God. Okay? Well, overweight is often defined based on BMI or body mass index at or above the 95th percentile. That's not really a fair thing because percentiles, you know, if everybody's getting really big, overweight is still defined as 95th percentile. That literally isn't right. Um, but it's serious problems, especially among ethnic minorities and stuff. I mean, there is a truth to the fact that it is expensive to eat healthy. It really is. Um, I saw something one time that shocked me. You could tell this. There was this woman at the grocery store one time. You could tell she was pretty poor based on a lot of stuff. She had 3, 4 kids with her. It was quite a few, and there was hot dogs on sale, 50 cents a pack, man, 50 cents a pack. It was probably a 12-ounce pack, maybe even a 1 pound pack. I don't know. And this woman had about 40 of those things in her cart. And I'm thinking, oh my God, those kids are going to be having hot dogs in their Cheerios. They're going to be having hot dogs in their oatmeal. They're going to be having hot dogs in their hot dogs. Actually, that makes sense. They're going to be having hot dogs in everything. And of course, these were the processed ones. I mean, they were 50 cents, all right? So, I mean, a hot dog by itself is nasty, but these were the nasty of the nasty hot dogs. And they have so much sodium in there and fat in there. They just grind whatever shit they can find and throw it in there. And this woman, you could just see that her kids were destined towards obesity and other problems just based on the fact that she had 30 packages of hot dogs in her. And I feel bad for her because I could just tell that that was the only way her kids were going to get meat. There was no other way meat was ever going to be served on her table if those hot dogs weren't 50 cents that day. So I feel real bad about it, but that is just how it works. Okay? Also, we rely more on fast foods. We're willing to pay more money for convenience than we ever did in the past. Our packages, I mean, even when we eat at home, half the work is done for us, that's another argument altogether. But yeah, we rely a lot more on fast foods, processed foods. Yeah, you want convenient, it's processed for you, right? It's canned instead of fresh. And I mean, I understand why. I got it. I live in the 21st century here. The percentage of children and adolescents who are overweight tripled since 1963 to 1970 survey period. All right, I know I'm going on again, but you know what? This doesn't even make sense based on the definition of overweight they just gave us on the last slide. If overweight is defined as being at the 95th percentile, then by definition there will always be 5% of children overweight. It is impossible to be tripling a number which is locked at 5% according to their definition. Whatever. I'm not being picky, I'm just reading the numbers. Okay? So that doesn't make sense. But yeah, I mean, this was from 1960s to 2000. And unfortunately, this has been speeding up. This seems to be all right, because this is, it's almost a exponential growth curve. And yeah, and it's different parts of the country, by the way, because I just came back from vacation up in Seattle in Canada, Vancouver area, and you just did not see the a number of overweight people that you see around Texas. It was a radically different setup up there, a radically different look up there. Of course, there are disorders of eating. This is not that class, but here it is. In particular, adolescent females are most likely to have these issues. Anorexia is a distorted image of body and self-starvation often, or massive exercise and stuff. Different ways of getting dangerously thin. And bulimia is binge and purge. And they both have their problems. Anorexia is issues because the body needs certain nutrients, and if you don't put it in your mouth, then it's going to find them, and it's going to burn off your body fat at first, and after there's no more food stored in the body fat, it's going to start to digest anything it can digest. It includes including the muscles of your own heart, and this can kill you by literally eating away your own heart. Bulimia is troublesome because it often involves a lot of vomiting, and that means a lot of stomach acids are coming up out of the throat, and those stomach acids aren't meant to come out the throat very often, and it can eat away and give you ulcers in your throat and your tongue and stuff. The brain and the nervous system are big deals. Take the biopsych class, man. That is a cool class. Don't you worry about that. The most complicated organ is the brain, and it's one of the first things to start developing. At birth, the brain and the head are already half their adult size. It's really kind of as an interesting side note. Some researchers have looked at it. So, maybe you've seen, they show, I don't know, maybe like Tom and Jerry Go to the Future or something, one of these cartoons, and they show humans with these big, big, massive heads like this. Well, here's the drill. There's a tough interplay between the process of giving birth and how big a brain should be, because yeah, there's a benefit for human beings to have a big brain. But what happens is that this baby's head has to fit through the mother's birth canal. And if a human baby's head was any bigger, the mamas would die at a rate which didn't make sense, okay? So those heads on a baby are as big as you can possibly get them. You can't get a bigger head than that. And so, in fact, what we find is that a human brain comes out very uncooked compared to other animals. Other animals' their brains are just about, they're already in place. They got it. It's set. But then again, they also rely much more on instinct than humans do. We're much more learning creatures. That's a different class, too. Okay? So, whatever. Here's what, if you could take a newborn and stretch him out to the height of an adult. I like this image. It's pretty genius. Look at how big their head would be. Right? That's just creepy, man. As kids get older, the size of their head relative to the rest of their body gets smaller and smaller and smaller and smaller. Okay? You see that? All of a sudden, he looks like he's got a little coconut head. But that's what happens is the size of the head compared to the rest of the body gets smaller because the head comes out so large comparatively at the beginning. The spinal cord, yeah. At the top is a brain stem, which just allows us to breathe and stuff. The cerebellum, this is all interesting stuff, but the most interesting of it is, and obviously, in addition to listening to these things, you actually read your textbook, right? You better. And you better be going back and taking them some time to be reading these in a heck of a lot more detail than I'm just skimming through them. Just because I say blah, blah, blah and move on doesn't mean you shouldn't be pausing and reading and looking and, okay? All right, that's your job. All right. But anyway, the cerebral cortex is the most interesting part. When it comes to the brain, it's all interesting, obviously. Good luck without it. But the cerebral cortex is the most interesting because that's, in fact, the part of the brain where we start to see, well, how about this? Look at your brain stem. It's called the old reptilian brain. In theory, I could pull out Dino the dinosaur and find that he's got exactly the same structures and functions in that part of the brain. You go to the middle part of the brain and you get to things like the limbic system, which is like emotions and stuff like that. And you find my stupid dog's limbic system is pretty much exactly the same as your limbic system. It's the same stuff. But then you get to the top, the outer cortex, the cerebral cortex, the outer layer. And it's often called the forebrain. And what you find is now all of a sudden, that part of your brain doesn't really map out the same as other animals. It's only here that we really become different. Okay? They break it up into different lobes. The most interesting of the lobes, they're all interesting, again, but in the cerebral cortex, the most interesting lobe, to me anyway, is the frontal lobe. The frontal lobe up front here is that part that's responsible for higher order thought, planning, understanding the consequences of our decisions, things of this nature, organizing, problem solving. Okay? The other parts of the cerebral cortex are usually involved in things such as memory. There's an image. Nice. Lovely. Okay. The brain is one of the systems in our body, and just like any other tissue in the body, it's composed of cells. Well, in the nervous system is composed of cells, just like every other part of your body, but these cells have a special name, and they're called neurons. Neurons are just special cells that are used, and these cells, just like any other cells, they have nuclei, and they have, DNA and chromosomes. It's all in there. It's all good stuff. But they serve a special function, and that is communication. They talk, they tell, they move information. Specialized cells controlling communication. The process involves impulses, electrical impulses that travel across neurons. I'm going to show you an image here in a minute. In fact, why don't I just show you the image instead and talk about it. Here's a single isolated neuron, and here is a second neuron. An electrical signal will be sent. Of course, there's a third neuron out here. A neuron will send the signal. This one will pick it up. It will send it along. It'll be sent it to here. We've called this the cell body. As I said, up in here, you'd find your mitochondria and your Golgi body, and I don't know what the hell else you do. What's your bio class? Electrical signals are sent down the axon here. The axon, this long tail. Okay? Notice that this long tail has got this little gooey substance on it, the myelin sheath. This myelin sheath, I'm going to talk about it in a couple of slides up. This myelin sheath, what it does is it allows an electrical signal, the signal to travel much faster. In other words, you can have much more efficient, much faster, much quicker, boom, boom, reflexive, bang, got it, faster behaviors. We find that at the end here, you see this image here is a blow up of this little area. Because it turns out that this neuron and this neuron don't actually touch each other. They come incredibly close to each other, but they don't actually touch. And instead what happens is when the electrical signal comes down to the end here, right, it stimulates this neuron to release something that are called neurotransmitters. And these neurotransmitters are chemicals that float into a liquid here. Very interesting, by the way. This liquid that's floating on here has the same chemical composition as seawater. So I know, that stupid evolution thing. So we left the ocean, we come up here, we grow ourselves some feet, and guess what happens? We brought the ocean with us. Oh my God, it's so cool. All right, so it's floating in there, and it attaches, and then when this attaches, this is not biopsych class, right? This is clearly not. But it stimulates this second neuron to fire, boom, boom, okay? So these neurotransmitters are hugely important. Again, this is not biopsych class or something. If it was, boy, oh boy, I would not just say, here's these neurotransmitters. But there are many kinds. Perhaps you've heard of some of these things like serotonin or dopamine or norepinephrine. There's just 100 of them. And they do different things, and they're located in different parts of the brain. Some parts of the brain, you find there's a lot of serotonin over here, and lo and behold, guess what? Those are the areas of the brain that are primarily associated with emotion. It's like, oh, serotonin and emotion, yay, hoo hoo. Over here you find there's lots of dopamine, and lo and behold, that's the area that's responsible for controlling movements. And it's like, oh, dopamine control. And it's a pretty complicated thing, obviously, but suffice it to say, these neurotransmitters are huge. And as I said earlier, in order to create these neurotransmitters, your body has to have certain raw materials, and it comes from the foods we eat. And it's actually kind of cool because, like, say when women are feeling depressed or down in the dumps, they'll often, we've seen the old stereotype behavior. Oh, they're gonna go out and stereotype, whatever. The cliche, I guess, is that the woman that breaks up with her boyfriend and then goes out and gets the Ben and Jerry's. And there's a truth to it because what happens is when you're feeling sad, an increased level of serotonin would improve your mood. And in order to generate serotonin, one must have the sweets, the raw material to create serotonin would come out of that Ben and Jerry's, believe it or not. I don't know if Ben and Jerry put that in there. That would actually be not a bad flavor, right? They got Chunky Monkey and it had Shreddy Balls for a while, and I think that, I don't know, the serotonin booster, I don't know, the Dumpy Man ice cream. Let's see, neurons, neurons, by the way, being smart is not having lots of neurons. You need a lot of neurons, don't get me wrong, but if person A has lots of neurons and person B doesn't have as many neurons, is person A smarter? No. It's not the number of neurons that makes you smart. It's the way that they're connected to each other. Okay? And in fact, there's an awful lot of what synaptogenesis refers to, the generation of synapses. A synapse, I don't think I said it on the last slide. The synapse is a name for this connect. I guess it says it right there. The synapse. A synapse, literally, to have a synapse implies that two neurons are talking to each other. And if two neurons talk to each other, that means increased complexity. You want to talk about intelligence, you might, from this kind of a thing, we would be saying you're smart if you have lots of synapses. Yes and no. You're smart if you have lots of efficient synapses. Because lo and behold, not only is there these synapses, which makes us smart. In fact, somewhere it says it in here. By 20 weeks in gestation, the cortex is 80 billion neurons, which is about what you're going to be born with. So the baby already has these neurons, but what happens is it starts to connect them and makes efficient connecting. We can talk about, again, this is not biopsych class, but we can talk about synaptic pruning, which is to chop off synapses that don't work anymore. I think actually I'm going to do that on a couple of slides up. Maybe I forgot that. And as we had already said, myelination is the growth of this myelin sheath around the axon. Okay? Most axons are myelinated even before birth, but some areas just don't myelinate for years and years, and we'll talk about this. What happens? Well, I'll do it when I get to that other slide. So there's an overabundance of neurons. I love that. And the brain manages to chop them off using programmed cell death. I think it was I can't remember the word. Whatever it was, apto something. But programmed cell death. And so having neurons is not necessarily a good thing. It's having synapses, not really exactly having efficient synapses. An efficient network is much better than a big mass of unconnected. Okay? Also in the brain, however, for every neuron, there's 20, 30 glial cells. Glial cells are the support structures. They hold neurons in place, for example, to make sure they don't float around. Yeah, it's kind of important. But glial cells also provide, they bring in the energy to feed, and they take out the poop. You gotta imagine neuron poops, right? Takes out the waste. It does, it does an awful lot. In fact, glial cells also, not only do they hold the neurons in place, but they also guide them. When neuron A wants to connect to neuron B, neuron A needs help getting from A to B, and the glial cells will literally guide the dendrites to move in the appropriate place. It's really a cool cool looking thing to see. Childhood to adolescence. Look at this, synaptogenesis. Here's birth. This is the growth of new synapses in the earliest ages. Then there's synaptic pruning, up until about 13 or something. After that, the brain is relatively stable, okay? And then it declines a little bit in later life. So this is really kind of cool. I mean, the number of, like we said, even before birth, the number of neurons is already set. We talked about neurons, but the number of synapses goes back very much, but inefficient at this point. That's the problem. You have so many of them, but they're not efficient. This process now, synaptic pruning, makes it an efficient connections, not just connections. Okay? Well, here's an interesting one. During adolescence, okay? In fact, here's a really neat article. I put it up on Blackboard. Check it out. It's worthwhile. It's National Geographic, dude. I love Geographic. During adolescence, the brain reorganizes itself. It's really, really cool. Because as we said, most neurons are myelinated even before birth, except in the frontal lobe in particular. Didn't I already tell you that the frontal lobe is the most interesting? That's the one that allows for planning and coordination and long-term understanding of long-term consequences and stuff. Very, very cool area. But what happens is that that frontal once a neuron is myelinated, it becomes much harder for it to. Didn't in fact, I just told you that the glial cells, one of their main jobs is to make sure that neuron A is in fact able to reach out and touch neuron B, right? The glial cells guided. It's a really cool process. But once a cell is myelinated, once a neuron is myelinated, it doesn't move so well. It becomes somewhat locked in place. I mean, they can still move even when they're myelinated, but it's a heck of a lot harder. And so the basic idea behind this is that during the teenage years, the brain then becomes reorganized in a massive way. And once it's reorganized and you're in your early 20s, then full myelination occurs. And the thought process behind this is that the adolescents need to have a brain that is what we call plastic meaning changeable, needs to be changeable because this is a time, I mean, we're going to talk later, but during the teenage years, this is where they start to have an identity crisis, like, who am I? What am I going to be? What is an adult, And so that brain needs to be able to modify itself to fit whatever they can. You're going to be a farmer. Oh, shit. Okay, now they need to learn the skills of being a farmer or a glass blower or whatever they're going to become. And their brain is going to restructure itself at this time based on these experiences as they're taking on their adult roles. Therefore, all kids have the potential to take on any different adult role they could possibly imagine. But at some point, they're going to myelinate and you start to get a little bit more locked in place. To some degree, the brain expects certain experiences. We'll talk later, but say, for example, language, or certain areas in the brain that are designated language centers. And the brain expects those experiences. Or something that is actually kind of important. There's certain areas of the brain that are waiting for input from sound. They're just waiting. It's like, oh, dude, just feed me. Just give me some information about sound. And so what we find is that certain language centers in the brain, which are just waiting for sound, if a kid is born deaf, those areas just don't, receive any input. And yet the brain is going, oh, dude, feed me, I need this. And your brain is so smart that it says, hey, you know what? I'm not receiving any input here. Dude, why am I putting all this energy to run this area that's not getting any input? And so, chop them off. Okay? Well, at the same time that we have some universal experiences, we as humans share universal experiences. Each one of us has our own unique setup. I was born in Wisconsin. I had different experiences than you did if you grew up in anywhere, whatever place you grew up in. Experience-dependent development refers to experiences that are not universal, and the brain is not expecting it per se, but it means that the brain is malleable enough and changeable enough to fit each unique situation. And this is really what learning is all about. Synaptic pruning is very important. Yes. The effects of experience on the brain depend on age and type of connection. Here's an interesting study they did. They take these rats and they put half of them in what they call an impoverished environment. Okay, it's standard laboratory housing. It's really what it is. They put them in a cage and they just live in a cage. Rats in what they call an enriched environment are put in here with other rats, and they get to play, and they get to interact with toys and all kinds of things, go up the ladder, and oh, I love you, ooh, baby, okay. For adult rats, enrichment creates more synapses. That's what enrichment does, okay? Which is not a bad idea. Synaptogenesis, stimulate. For newly weaned rats, right? These are just fresh pups. Enrichment creates fewer synapses per neuron. There's actually synaptic pruning. In both cases, by the way, it makes for smarter rats, but in this case, it makes it smarter by making the network more efficient. Very cool. Plasticity is a generic word, as I think I already threw it out there, but it refers to the flexibility or malleability of the brain to change itself. Brains are plastic throughout your life. They really are. I mean, all you got to do is see somebody that had a stroke and to watch how good how much recovery they have after the stroke, and it tells you that the brain is plastic even into old age. It's greatest before age 2. That's clearly the best. That's why the old feed your kids info when they're young. From age 2 until adolescence, it declines. And again, there are periods, opportunities there where plasticity is greatest, and children are just ready the most at certain points. Okay. The eyes, or say for example, they've done studies. I know it's cruel. I didn't do them. They did them. I don't know who they are. Okay, but they take kittens and they put it over their eye. It was like that. All right, and the kitten runs around, and then 3 months later they take it off. The cat will never see out of that eye, okay? Because what happens is that the parts of the brain that would have been responsible for allowing this eye to see are now designated for something else. Often it's going to be this eye. So in some ways this will be a super eye, and this one will be blind, okay? And that's what happens. They just degenerate. They don't just the brain doesn't disappear, but the connections change as a result of it. Other areas, language centers, up to age 12. Here, for example, children can learn a second language and speak it with the accent of a native speaker if they learn it before age 12. But if you pick up a second language after age 12, you're pretty much going to have an accent. Yeah, that's right. All right, here's interesting. Development of perception. This is pretty cool. What are babies able to perceive? All right. Preferential looking techniques. I don't know. Here we go. This is one technique. It's pretty crude. They got this kid and they put him in a box. Baby in a box. And they put some images on the ceiling in the box, and then this guy just looks and he's measuring how long the infant looks at this. And then you can do this and find out what the babies enjoy looking at. Babies prefer to look at things that are moving. They prefer things with outer contours or edges. I still remember at the hospital, I think it was my second kid, they gave us a book. It was great. It was called The Shape Book. Each page, it was all in black and white. I mean, glossy black and white. And they were just like a white square on a black page. Honest to God, there was an author on the book. That was just nuts. They like these sharp color contrast, black, white. They like patterns with some detail or complexity. So some of the shapes were like stars. Okay. They like symmetrical patterns. Okay. They like curved patterns, right? So there's some circles and stuff. But they also liked patterns that resemble the human face, and that's kind of cool. I'm going to come back to that, but they liked that. And when it came to human faces, even at 2 months old, they preferred to look at faces that, a bunch of adults say which face is more attractive, and the adults go, oh, that's the more attractive one. The kid who's at 2 months old already prefers to look at an attractive face. I don't know how they know how do they know what that means? Okay, well, they do. They can figure something out. You see that this is, how much, percentage of total looking time. How much time they spend looking at a dark red circle, a white circle, a fluorescent yellow circle, newspaper, a bullseye pattern, or a human face. And so, lo and behold, babies are just born ready to prefer people, right? To look at people, to interact with people, to socialize with people. Because we're going to talk about social development later. And social development is not a one-way street. It's not just that, like, the children absorb everything mama does. No, babies are an active participant in the social interactions with their parents, okay? So they far prefer the top left image to any of the others. I can't blame them. Those Picasso-esque images are kind of creeping me out. Here they hooked up. I don't know how they hooked this up, but they put little eye tracking little glasses on a baby, and where's the baby looking? When the babies are about a month old, they focus on the edges, as we said, that like that white circle on a black page. They just like the contours. So this is where the earliest gazing is for the youngest kids. But as they get older, 2 months old, they don't just focus on the outside edge, but they start to go into the pattern in the middle. Okay, those are the most important ones, because clearly, if you want to know what this guy is thinking and doing and what this guy is, you have to focus on here. Focusing on here doesn't tell you anything about this person at all. This is how we, as sophisticated adults, figure out, say, for example, this guy's emotions and feelings. This is interesting. Let's say, let's say, for example, I could ask you, can you tell the difference between this circle? I don't have any circles. Oh, I got it, 4 and 6. Can you tell the difference between 4 and 6? And you could say, why, yes, I do see 6 and 4, and I understand that those are different numbers. Now, that's cool, but now let's say you wanted to find out if an infant could tell the difference between 4 and 6. How do you do it? You can't ask them. Well, you can try. It ain't going to work. So what do? You go like this to an infant. Okay? This is called the habituation technique. You go, here, baby, and the baby's like, oh, yeah, here, baby, and the baby's, oh, you just keep doing it over and over and over. Okay, got it. Eventually, the baby's bored. Okay? Something happens called habituation. And they stop looking. And you're putting it up there and going, here you go, baby. And they're like, dude, kidding me? Come on, I'm done. I'm bored. Okay? So then, okay, cool. I got it. Now, if I put this up, oh, baby. And the baby's like, whoa, that's cool, man. Clearly, the kid can tell the difference between 4 and 6, right? Without, if the kid, if you show this 6 and the kid's like, yeah, okay, I'm bored, then the kid cannot tell the difference between 4 and 6. Okay? So it's just a technique which allows us to figure out what a baby can or cannot perceive. Can a baby perceive the difference between yellow and green? Find out. Habituate the baby to green, and then change it to yellow and see if the kid is interested. Okay? Very interesting. Dishabituation refers to the recovery or increase. Yeah. Okay, so it's a really cool technique for finding out what a baby does or does not know. And so here, like say for example, what you could do is you show the baby, here baby, and the baby looks for 5 seconds. And then you put it away, and then you bring it back, oh baby, and the baby looks for 4 seconds. Oh baby, and then the baby looks for 3 and 2, okay? And if you keep going with the same one, the kid's like, forget it, I'm not interested. But now if you change it, and you bring out something with a new color but having the same form, look at how much time they go, oh wow. If it's a new form and the same color, if it's a new form, new color, if it's a new one, and so the more different something is, the more time they will then spend on it. Okay? So it's kind of a neat way to access a baby's brain. They can use the same types of techniques to find out the visual acuity or what kind of discriminations a baby can make. And it turns out that, say, for example, these two are viewed as the same thing to infants that are very young, all right? That is to say, this solid pattern and these lines are the same. But as the kids get a little older, they see a difference between these two because their visual acuity gets better. And later on, these two are viewed as the same, and then, this kind of a thing. And our full functioning visual acuity then as adults tells us these are different, right? Yeah, okay, whatever. They do some other studies. Here, for example, is called the visual cliff, and we want to find out about the ability to detect depth perception. And so what you do is you put a baby on here, right? And this, by the way, is plexiglass, okay? We're not going to allow babies to take head dives. However, to this baby, in many ways, it looks like it's just falling off. You know, you could look down and go, oh my God, okay? And so what you do, you stand out here at the edge. You bring out your keys, man. That's the way to get a baby. If you ever had a baby, you'll know this is the most interesting thing. They will shove this in their mouth all day long. Come here, baby. And this baby, if this baby has just learned how to crawl, we'll just go right over there and go, give me the keys, man. But after this kid has learned how to crawl for about, I don't know, 3-4 days, something like that, you go out there and, oh, here, baby. And this kid, he's going to get to the edge. Going to look over and look at you and go, no, there is no way, Mom. I am not coming over there. You're nuts if you think I'm going to crawl over there. Okay? So you can use this type of a procedure to find out when children are able to perceive death. Yeah, infants speak, yeah, blah, blah, blah. Yeah, infants and young children are more sensitive to higher frequencies of sound. As we get older, we lose the ability to hear those higher frequencies. That's why I've heard that some teenagers' tricks, what they'll do is they'll set their ringtones on their phones to a really, really high pitch. And by doing so, what happens is they can fool their teachers because the teachers don't know they're ringing, right? Because teachers don't hear them. That's cute. I've also heard it being shot right back at the teenagers, and certain businesses that are having problems with young punks hanging outside the front. They'll just blast this high-pitched noise once in a while, and it doesn't affect paying customers. I mean, the real customers, the ones that actually have money. But the teenagers find it really annoying, and they leave. Oh. Turns out that kids seem to have a sense of smell and taste that are fairly mature fairly early. Facial expressions, infants seem to react to odors like we do. Throw them into a stinky bathroom and they go, ugh, just like an adult does, you know. Infants are capable of discerning small differences in a complicated odor. They have taste preferences immediately. They tend to prefer sweet things almost immediately. They like sweet stuff. Anybody that's ever had to feed their kid the Gerber baby food, they know the dessert is easy to feed. The strained peas are not. Okay, it's a real mess. I mean, when you try to feed a kid strained peas, they're looking at you like you're kidding, right? This is interesting. However, most of our senses are not isolated. They're actually the way we interact with the world. We have to put these together. In fact, I'm going to describe a study later. I don't remember when, but this one which was really cool. And what they did was they took a pacifier, and the pacifier was either smooth or had knobs on it, a little knobby thing. And then the kids sucked down, and then later on, they sucked on one of the two. And then later on, they showed the two pacifiers, and the kids preferred to look at the one that they had sucked on, whether it had been the smooth one or the knobby with one. And that's pretty cool, because it's pretty complicated what that kid has to do. That kid had to, it was sucking on it, so the kid felt it with his tongue and mouth and had to sort of turn that into a mental image in their brain of what it looked like. Because, I mean, clearly later on the kid preferred to look at it. So clearly that kid had to have some kind of a mental representation of what the visual object would look like. And it's like the kid is 2 months old and he's able to do such an incredibly complicated intermodal perception. It's a pretty cool technique, pretty cool thing. We're going to look at it later, and it's actually going to be a big critique of Piaget, because Piaget would have never, ever predicted such complex cognitive reasoning in somebody so young. Okay? Well, it turns out that an infant's ability to do this type of thing, this intermodal perception, is strongly predictive of cognitive functioning later on. So it's a pretty amazing skill. Infant deaths, all right, they do sometimes happen. Of course, we've heard of shaken baby syndrome. I can understand how something like that happens. I really can. It is so frustrating. And so, it's 2 in the morning. You're just exhausted. You're exhausted. You haven't had a night's sleep in 3, 4, 5 months. I mean, this is psychological torture. The CIA needs an interrogation technique. This is it. This is it. Give him a baby. 3 months into it, and the kid is screaming, and it's 2 in the morning, and just nothing is making this kid happy. Nothing, nothing. And so what are you going to do? And so I can see how some of that stuff does happen. That is some crazy shit. But anyway, more often though, it's things such as birth complications, diseases in the first year. After 1 year of age, death rates drop and then rise again during adolescence because teenagers are stupid. Oh, we saw it. It's not their fault. It's their brain. Well, it doesn't change the fact that they're stupid. Okay? Teenagers are dumb and they do dumb things. This is an interesting thing. This notion of infant mortality in the Korean culture. There are two significant dates. One is at 100 days old. According to traditional Korean culture, you are not supposed to allow anybody outside of your family to see the baby for the first 100 days. Because what happens is there's a fairly high rate of infant mortality, which is one of the major peak points is 100 days. And if the baby can make it for 100 days, you're really feeling confident because that's where the majority of the problems would occur. But then there's a second age, age 1. At 1 year of age is a significant age as well, because again, it's this infant mortality thing. If your baby made it to 1 year, and in fact, in some cultures, I'm thinking in one area of China anyway, off the top of my head, a baby is given a name at birth, and then at 1 year is given their actual name. Okay, the first year the baby doesn't have a real name per se. They have, in fact, they have sometimes funky names for the baby to try to fool the spirits, so that this evil spirits wouldn't try to steal your baby. So you call your baby like Ugly Pig or something like that. And so for the first year, your baby's name is Ugly Pig, and that way the spirits will not try to steal him because it's not, dude, it's an ugly pig, right? So something like that, and then not until the kid is 1 year old do they give it an actual name, and literally that's when the child becomes an actual person in their culture. Car seats, those things are really complicated and very frustrating. If you're going to have an infant, get your car seat properly installed before the baby is born. Okay. Yeah. Okay. Sometimes children get maltreated. It's a terrible thing. Child abuse includes beating, slapping, hitting, kicking, burning, shaking baby syndrome, as we said, all kinds of funky things. I understand the problems with child maltreatment, but I think we've gotten to the point where we're too afraid now because if a parent gets labeled as an abusive parent, or child protective services comes in on you, you're screwed, man. You can't get your kid back. I can tell you this is an interesting story. They in Asian babies, when Asian babies are born, the majority of them have this thing right on their back, right in here, called a Mongolian birthmark, and it's usually it's pretty good size. I mean, it covers half of their back, and it's usually like it's the color of a really bad bruise. I mean, that is the color of it. And these babies are born with this thing, and it just is. It's just how they are. And this one family that we knew at one point up in Missouri, they had a daughter who, in fact, was autistic, and I mean, they had their issues, of course, and stuff. Well, one time at preschool, they had the girl in preschool, and they were changing this girl's diaper, and they saw this Mongolian birthmark, and they called Child Protective Services and said, hey, they're beating their kid, they're frustrated, the girl's got autism, and they lost control. Child Protective Services takes their baby, even then they're like, they brought from the hospital the documentation showing, they showed them, look, this is common in this culture. It took them 2 weeks to get their kid back. 2 weeks to get their kid back from a birthmark, okay? Now, I understand how come it's important. But you know, every time when my wife, when we brought our kid into any kind of a daycare center, whether it be at the church or whatever, my wife, she'd be like, okay, take a look at this. This is a birthmark. This is normal for babies from Asian cultures. It's not da-da-da-da-da. And by the way, that birthmark, it goes away. My kids, it went away about 2 years old. And so she was just all crazy, hysterical about it. And I mean, I understand why we need to be careful. But at the same time, we as parents, we need to be able to say, we'll talk about it later, but we need to be able to discipline our children without being worried about Child Protective Services coming in and taking away our kids. If my kid's a little shithead, he's going to get spanked. All right? That's life. We'll get to the details. Don't think I'm beating my children, all right? Neglect, on the other hand, is failure to provide for a child's basic physical, educational, and psychological needs. Yeah, this is another recurring theme we're going to talk about, and that is when you signed up to have kids, you thought, hey, baby, let's have a night of fun, right? Well, guess what? You have signed up for a lifetime commitment, and many parents ought not be parents, okay? That you will have to put your child ahead of yourself in many ways. You will have to sacrifice things that you want for your children. You will have to go places you do not want to go. You will have to not go places that you do want to go. I mean, you will have to, your foods will have to be, etc. Well, some parents just are not able to sacrifice themselves in the way that is necessary for those children, and that's where neglect tends to arise. Those are mostly in unwanted pregnancy situations. Child abuse and neglect is, there are cultural differences. Sexual abuse, yeah, what can I say? You can read that. Child maltreatment, who does it? Mothers more often than anybody, but that's mostly because they're the ones that interact the most. Maltreatment, etc. Yeah, that's kind of a depressing way to end this chapter. All right, suffice it to say, we have wrapped up a little bit about physical development, and I said it, and I'll say it, and I'll say it, and I'll say it. Don't even think that we are actually talking about one type of development in isolation of the others. We're just presenting one first, and as we come along, we'll have the ability to have more complicated, more complex discussions about the interactions between development and different types of development. But it's a constant factor that's always going to be there. All right. See you next time.